Let's talk making rack and pinion systems in Alibre and how that can easily be done. For spur gear generation in Alibre Pro and Expert is quite easy, as we just jump into a script, we launch a script, and then with Alibre we have examples that ship. One of those is a mechanical example. I'm going to go with gear generator, run, and say I want to have 20 teeth. Let's make a diametral pitch of 1 and be easy on ourselves, and make a pressure angle of 20. Now this actually is a large gear that's going to come out pretty thin, so I'll even edit this and give it a pretty standard 5. And there we have a gear. So I'll save that as a gear, and then let's move on to a rack. So here we have another new part. Let's go ahead and sketch on our XY plane. We want to make a rack, so we want straight lines, and I'll actually center this so that this plane is the pitch line of the gear. So from that plane to there, we will actually want to have the distance be our module. And module is 1 over diametral pitch. I just made a gear with a diametral pitch of 1, so in this case we're going to type in 1 divided by and our diametral pitch value, which is 1. So that's going to come out to 1, and then we want to make our dedendum. So we're going to say 1 divided by, again, our diametral pitch. That converts it to module. And we're going to multiply that 1.25 times that value and enter that. Next, I'm going to make some lines there, and we're going to make sure that they're horizontal. So we'll say horizontal, horizontal, and then I'll choose equal. And this line are equal. And I did that just so that things would be centered. And then we want to have our pitch divided by 2. Now pitch is our diametral pitch, so we're going to say pi divided by the value of our diametral pitch, which is 1. And then we're going to divide that by 2. Finally, I'll grab a horizontal and finish up this tooth profile. Maybe I'll even just make a line right there. And we'll make sure that this line is horizontal. And we'll make sure that these two lines are equal. Alright, so now what angle do we want these lines to be? It's one of the only things that we need to constrain left. So it's a pressure angle. So most gears are a pressure angle of 20. And so if the spur gear that you're working with has a pressure angle of 20, put a 20 right there. Other gears might be 14.5, so you can do 14.5 there if that is for you. Let's go ahead and extrude this tooth profile. And we want to pattern this, of course, according to our pitch. So again, we'll do a linear pattern. And we'll take our linear path, and we'll say, take our diametral pitch. So that would be 1. We're going to say pi divided by 1, or pi divided by our diametral pitch. And I can create a whole bunch of linear instances here. And maybe I'll add a rectangle just to connect all these teeth so it looks more like a good rack, right? So we're going to go coincident to there. We'll take this point, coincident to there. And then this line coincident to the bottom of our teeth. I can add a distance here, maybe 1, extrude. Oh, and I should have extruded that in the other direction, so we'll say reverse. Now if we want to add a fillet on the bottom, the max we can do is 0.38 times our module. Of course, module is 1 divided by the diametral pitch. So we're going to say 0.38 times, we're going to say 1 divided by our diametral pitch, which again is my case 1. And I can add that again. Right, so we can, this is the maximum value that you're allowed, as I understand. So we'll apply and close. Now, we'll go ahead and save that as a rack, and then let's put these together. So in our new assembly, I'm going to just stick in our rack and gear. We'll show our planes, and I want my gear to spin around this axis right here. So we'll add a constraint for that. I'll say that this face will go flat on this plane, and this face on this face. And now, what distance do we want to have these be apart to mesh? Well, we know that we want our pitch line here to be tangent with the gear's pitch circle here. And because I know that we have a 20-inch diameter pitch circle diameter here, that we want from this plane to be 10 inches from the tip of this pitch circle. So if we look at how we made this gear rack, and I take a look at my first sketch, I know that I want this construction line to be tangent with that pitch circle diameter of our spur gear, and it's 1.25 away from the base of the tooth. We'll generate to the last feature, head back to our assembly here, and so I'll choose the plane at the base of our tooth here, and I'll choose this plane here, and so I'll take, of course, a distance that consists of half the pitch circle diameter of our spur gear plus the 1.25 distance that we just saw, and that should be right. Now we'll move this so that the teeth aren't interfering, and when we come to a position that we like, I'll say add another constraint. We'll go mechanical. The first thing I'll choose is the line along our rack. The second thing I'll choose is the circular face that corresponds to the center of our gear. I'll choose the rack and pinion mate, and it says pitch diameter, but I also like just entering the number of teeth on my spur gear. And it's moving backwards, right? So I'm going to hit Control Z. We'll go to our rack, and we're just going to reverse relative rotation right there. And now we've got a rack and pinion mate in Alibre over things that we have just made. And I think we did so around 10 minutes. So pretty quick time to do everything from scratch. And I hope this was helpful. I originally had some involute curvature, right? Like the curvature on this tooth on the rack. And it was pointed out that that was not needed. And as I looked into it, I found that racks have an effectively infinite diametral pitch, and as things approach infinity, this approaches a straight line from being a curved. And so that's where I found that we have straight lines on racks. Thank you for those who pointed it out. And so if this is helpful, please subscribe, and I'll see you in the next video.